So sometimes you're given equations in this form, and think about how beautiful that form is. We know what the A is, we know what the B is, the H factor, of course, which moves us left and right, and that ends up being our vertical asymptote. Oh my goodness, how pretty. We know what the K value, which moves it up and down, that becomes a horizontal asymptote, and we're laughing ha 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 all the way to the bank on this one. But sometimes I give you an equation that looks like this. Do you remember? We manipulated this guy. We got the common denominators. We add them together, and we got that monster. And if you think about it, the only thing that you can get out of this right now without just going out and graphing it on your calculator, the only thing you get out of this is you find out what the vertical asymptote is by saying x minus 1 cannot equal to 0, so x equals to 1, right? I get more out of this equation. So what happens if I give you an equation like this and you're asked to go back and describe all the transformations? Oh boy, well guess what? You got to put it back into this form. Ah, I see, because then again, there's your A, there's your H, there's your K, and you know your B in this case is 1, right? So that's really important to know how to do it. Now, the book does it some really cool ways. Okay, they do some really wonderful things in the book, but sometimes that can be really, really confusing. So I'm going to show you a little bit about what the book does, and then I'm going to go back to this guy. Do you remember division statements in the polynomials unit when you divided and you ended up with a remainder? Oh, you're going to love me for this one. This is the easiest way in the world to do it. Watch this. Very, very cool. Okay, so let's do what the book wanted you to do first. Okay, so what the book asks you to do first is this. It says create a common factor with the numerator and the denominator. And then you're going to end up canceling this. Why? Well, the common factor that you want to find is this one here. This is the common factor you want to find because when you cancel it, you end up with a K value. Oh, kind of, sort of see it. Okay, now how are you going to do this? Let me show you how you're going to cancel this out. Just look at this section right here for a second, right? If I wanted to cancel out an x minus 1 here, watch what I would do. I would take the 3, I would make the x into an x minus 1, and have the x minus 1 here. Now, why did I put it in brackets? Because I'm going to hold on to that value of 3. Okay, that becomes very, very important because watch what happens. If I cancel them out, I just have a 3. There's my K value. Oh my goodness. See that? But I can't just go out and put an x minus 1 up top, or can I? Remember the wonderful thing that we called completing the square last year, right? In Math 20-1, where we completed the square and we said, if it doesn't behave, throw it out of the house. Same kind of idea. Same kind of idea. Watch this. This is really, really cool. So honestly, then, I'm going to take this guy here. I'm going to go and I'm going to make it an x minus 1 because there's that factor right here in the denominator that I want to cancel out. And I'm just going to go, okay, let's see what we got. We have 3x minus 3, right? Well, I can't just throw in a minus 3, right? Or can I? Remember, this becomes a 3x minus 1 here with the x minus 1 on the bottom, right? Here's that minus 2 that's there, but check this out. Because I distribute here and here, I created an extra minus 3. So what I'm doing is I'm subtracting 3. How would I get rid of that 3? Simple. Just like completing the squares, you would add 3 to the outside. Add 3 to the outside. Look what you end up getting. You end up getting 3x minus 1 over x minus 1, right? Plus 1. Now, check this out, what you can do with it, right? Divide this and this by x minus 1, so you're going to get 3x minus 1 over x minus 1 plus 1 over x minus 1. Check this out. That cancels, leaving you with 3 plus 1 over x minus 1. What? That gives you that. So y equals to then, real bold letters, y equals 2, 1 over x minus 1 plus 3. Now you can see that the vertical asymptote is 1, the horizontal is 3. Now, I know you're saying to yourself, wait a second, can you prove this? Yeah, I can prove that those are exactly the same, just like I did before by throwing it on my calculator. Okay, here we go. Let's put that original thing up there. I'm going to use alpha, of course, numerator over denominator, 3x minus 2 over the denominator of x minus 1. Now remember, this is going to be in blue, right? And it's going to graph, so let's graph it. It's going to look like that. Now, if I go back to y equals 2 and put that new value in, the one that I manipulated, right? I'm going to go alpha 1, here we go, 1 over x minus 1, right? Pop it out, put the plus 3 in there. Think about this. I started off with blue, right? And it's going to just trace right over top of it and replace that graph with a red graph. Ready? Check it out. Graph me. Look at that. You know you did it right if those graphs line up one over the other, just like that. Oh, that's just amazing. So you know that these two things actually work. So describing the transformation, simple. 1 unit left, 3 units up, you are done. So what do you do with this division statement stuff? I said earlier, yeah, I could just do a division statement and it's easier. Okay, so here's how I'm going to do the division statement. I'm going to leave this guy right here. I'm going to get rid of all this other stuff here. I'm going to leave what our answer is right now. Okay, do you remember synthetic division? Do you remember synthetic division? I do. I love synthetic division. I'm going to take this guy and I'm going to remember x minus 1 equals to 0, x equals to 1. There's my synthetic division starting off right now. 1, zoop, zoop. Uh-oh, take a look. See, I've got a 3 and a minus 2. Bring that down. There's 3. Okay, 3 times 1 is 3. Add them together, I have a 1. That is, of course, my beautiful statement. There's my leftover. Okay, so what is your division statement turning out to be? Simple. Okay, my division statement is 3 plus my remainder over what I divided by. Rearranging this, tell me if this doesn't look the same. I think doing the division statement is far easier than doing all of that stuff by trying to put in some sort of canceling value. But you know what? By putting that stuff in the way the textbook does, gives you such an appreciation for algebra. Now, stay tuned. I'm going to do this one in the next podcast. Watch this.